Hey, this is the video for 3.6, Age Structure Diagrams. So go ahead and check out the overview and set up your guided notes. So one type of age structure diagram is a population pyramid. And a population pyramid is a graphical illustration of population by age and sex. Now when we're talking about sex and gender, we are talking about the sex that was assigned at birth. We are not talking about a person's preferred pronouns or anything of that nature. So throughout this unit, that's what we're going to be discussing. So we're separating it by cohorts, and cohorts are groups within a population. Right now we have separated, typically you'll see males on the left and females on the right. And we have the pre-reproductive cohort, or individuals that have not reached reproductive age. We have the reproductive cohort, which is individuals that are able to reproduce. And then we have post-reproductive, and that is individuals after they've reached reproductive ages. Now, what we're really concerned with is the pre-reproductive cohort, and you'll see why in a little bit. I'll be discussing that as well. So we have different types of population pyramids. There are 4 types of population pyramids that we will see. And we are basically looking at the shape of them. So with a population pyramid that looks like this, like an actual pyramid or a triangular shape, we have a much wider base. And that is showing rapid growth because the pre-reproductive cohort is larger than the reproductive cohort, which is far larger than the post-reproductive cohort. So when these reproductive individuals or pre-reproductive individuals get older, the base of the pyramid will be even wider when their children are considered. Now we have slow growth, and slow growth is where the pre-reproductive is just slightly larger than the reproductive. If you notice, rapid growth, the pre-reproductive is much larger than the reproductive. When slow growth, it looks more like a blade of a knife, for example. It is still wider at the base than it is in the reproductive, and the reproductive is still wider than the post-reproductive. Now, when we talk about zero growth, you're never going to see something that looks perfect. However, with zero growth, it is relatively straight line between, or they're relatively equal sized. And then they will start dying off in the post-reproductive cohort. But typically, the pre-reproductive and the reproductive tend to be roughly the same size. Now, once this population ages, you may see negative growth. And negative growth is when the pre-reproductive cohort is smaller than the reproductive cohort. So this is, again, showing negative growth. So you should pay attention to the different shapes. These different shapes are, you're not going to see exactly the same shape, but you're going to see something that kind of is similar to that shape. Now we have what is called population momentum. The reason why like a rapid population growth might occur is because if you have, let's just say we have 3 different cohorts. And we have the pre-reproductive, the reproductive, and the post-reproductive. Well, these individuals are going to age and become reproductive. So when the yellow individuals age, if you notice, their population didn't change, but they had babies. So if each one of these individuals is having 2 offspring, basically your population is going to double every single generation. So the first generation we have 2, then we have 4, then we have 8. Now the next one we're going to have 16, and the next one we're going to have 32. So because of this, it is very difficult to slow down a population within 1 generation. So this population momentum, culturally the parents are used to having 2 children or 4 children or whatever number of children each, and their children are roughly going to have probably around the same number of children. It takes a generation or 2 for this momentum to slow down. Now, here's an example of a question. If the population is 50 million, what's the population of pre-reproductive males? Well, in your population pyramid, you will often have percentages. So these numbers represent percentages. So when we're doing an example like this, we want percent over 100 equals part over whole. This is just a proportion. So the total population, that would be the whole, Oh, the whole population is 50 million. But let's look at the pre-reproductive cohort. So we have 8 of the youngest, so this is 0 to 5. And then we have 5 to 10, that is maybe 7 individuals. And then from 10 to 14, or 10 to 15, we have 6.5 individuals. So 8 plus 7 plus 6.5 is 21.5. So 21.5 equals x over 50 million. When you solve for x, the percent or the number is 10.75 million. Now the reason we could do this is because we were dealing with percentages. Okay? So what I would like you to do now is show me what you have learned by completing this practice problem set 3.6. I hope that this video was informative. I thank you for your attention, and I'll see you soon.